Everything we believe about the beginning of the universe rests on a model built in the 1970s. For 50 years it held. It was the best idea science ever produced. Then we built a telescope to go and check. And it sent back something the model cannot explain. The data has been published. The astronomers who found it gave these objects a nickname. They called them universe breakers. But that crisis, the one happening inside the science right now, never reached you. You got the pretty pictures instead. By the end of this, you'll know exactly what the James Webb Telescope found at the edge of time, and why the most important part of the story was the part nobody put on the news. For 60 years, we told ourselves a story about how everything began. It was a good story. It held together. It explained the faint glow of radiation left over from the birth of the cosmos. It explained the way galaxies cluster across the sky. It explained the exact proportions of hydrogen and helium that fill all of space. It was, by almost any measure, the most successful idea in the history of science. The story went like this. The universe began small and hot and impossibly dense. It expanded. It cooled. And in the cold and the dark, slowly, structure began to assemble itself. First, faint clumps of gas drifting together. Then the first stars, flickering on one by one in a universe that had never known light. Then small, ragged galaxies, messy, chaotic, half-formed. And only after billions of years did those small galaxies collide and merge and grow into the vast, ordered spirals we see around us today. Slow, gradual, patient. That was the rule. Building a galaxy takes time. Building a mature galaxy, one with hundreds of billions of stars arranged in real structure, takes a very long time indeed. The model was specific about this. There was, in effect, a speed limit on creation, and the infant universe was supposed to be far too young, far too raw, to have broken it. That was not a guess. It was a foundation. Everything else was built on top of it. And then we sent up an eye to look back at the very beginning. The James Webb Space Telescope is not simply a better Hubble. It is a different kind of machine entirely. Hubble sees the universe in visible light, the same light your own eyes would recognize. But the oldest light in existence has a problem. It has been traveling for so long, and the space it travels through has been stretching the entire time, that the light itself gets stretched with it. Its waves are pulled longer and longer until they slip out of visible light completely and into the infrared, the heat part of the spectrum, the part your eyes cannot see. This means that to Hubble, the most ancient objects in the universe are almost invisible. Their light arrived in a form Hubble was never built to catch. But Webb was built for exactly this. Webb sees in the infrared. To Webb, the oldest things in the cosmos do not vanish. They glow. And there is something else Webb does that nothing before it could, because looking far out into space is the same thing as looking far back in time. When you see a galaxy that is billions of light years away, you are not seeing it as it is now. You are seeing the light that left it billions of years ago. You are looking at a photograph of the past that took the entire age of the Earth to be delivered. The further Webb looks, the deeper into history it sees. So when Webb opened its eye and aimed it at the darkest, emptiest, most distant patches of sky, it was not just taking pictures. It was reaching back toward the first chapter of the universe itself. It was looking for the faint, formless, just-born galaxies the model had promised would be waiting there. That is not what it found. In light that left its source when the universe was only a few 100 million years old, a tiny fraction of its present age, Webb found galaxies that were not faint, not formless, not newborn. They were bright, they were enormous, and they were already organized. They looked like galaxies that had enjoyed billions of years to grow. Except the universe around them was not yet billions of years old. There had not been enough time, not even close. By every rule we had ever written down, these objects could not possibly have assembled so fast. The mass was wrong. The structure was wrong. The sheer maturity of them was wrong. The first reaction among the people who saw this was not joy, it was disbelief. The assumption was that something had to be broken. Maybe the distances were miscalculated. Maybe closer objects were posing as distant ones. The telescope was brand new, and new instruments make mistakes. So they checked. And then they checked again. Independent teams, different methods, the same patch of impossible sky. The galaxies were real. The distances held. And the early universe, in its very first moments, was already full of things the most successful theory in the history of science said could not be there. To understand why this is not a small problem, why it is not a footnote that some clever adjustment will quietly absorb, you have to understand what a galaxy actually demands. A galaxy is not just a smudge of light. It is hundreds of billions of stars bound together by gravity, often turning in a structure with a defined heart and shape. Every single one of those stars had to be born from collapsing gas. That gas had to cool and gather and reach a density where it could finally ignite. And all of that costs time. Measurable, predictable, unavoidable time. The model handed the early universe a budget. So many million years to forge the first stars. So many more to gather those stars into the first small galaxies. The arithmetic was not vague, it was exact. And the galaxies Webb found tore straight through that budget. To exist as they appeared, they would have had to begin building stars almost the instant the universe was cool enough to permit it. And then keep building them at a furious, relentless rate, never pausing, never suffering the messy interruptions the model had predicted. Some of these early galaxies appear to hold as much mass, locked-in stars, as galaxies that took the entire age of the universe to assemble, all of it compressed into the first few 100 million years. It is the cosmic equivalent of walking into a forest of full-grown ancient trees, standing on soil that you know, for a fact, was bare rock a week ago. This is the moment the scientists gave them their name. Universe breakers. Not a quiet name, not a cautious one. The researchers themselves understood exactly what they were holding, something that broke the framework. And here is where the real story begins. Not a story of secrecy, a story of what gets through to you and what gets lost on the way. When a discovery shatters a foundational model, only a few things can be true. Either the measurements are wrong, and they have been checked and rechecked by independent teams who keep arriving at the same answer, or our model of how galaxies form is wrong, which would mean rewriting our understanding of how the first stars came to be, or something even deeper is broken. The timeline itself, the age of the universe, the rate at which it has been expanding, the very ruler we use to date everything that exists. Sit with that for a second. Each of those possibilities is colossal. Any one of them, fully confirmed, would stand among the most important scientific events of the century. If you have come this far, You are the kind of person who wants the part of the story that does not fit on a magazine cover. That is exactly what this channel exists for. Subscribe, and every week we go to the places in the universe where what we were told stops matching what we actually found. So you would expect this to be everywhere. And in a sense, it was. There were press releases, there were headlines, there were stunning images shared by millions of people who had never thought about cosmology in their lives. But watch what survived the journey to you, and what quietly died along the way. What survived was the spectacle, the deepest image of the universe ever captured. Glittering fields of golden galaxies, the telescope that cost $10 billion and unfolded perfectly 1,000,000 miles from home. That part was irresistible, and it traveled everywhere. What died on the way was the crisis, the actual structural emergency unfolding inside the data. Because explaining why a few too bright smudges threaten the entire timeline of creation is hard. It does not fit in a caption. It cannot compete with a beautiful picture. And so the most important thing Webb ever did, the thing the astronomers themselves were openly alarmed about, got compressed down into the same 3 words every space story gets: stunning new image. The scientists did not hide this. They were loud. They were honest. They published. They argued. They sounded genuinely shaken in their own papers. But their language is built for rigor, not for drama. They wrote phrases like tension with current models and challenges to the standard framework. Careful, measured, deliberately undramatic words. Exactly the words the scientific method demands. And those words, true as they are perfectly designed to slide past you without ever raising your pulse. So the result, for almost everyone outside that small circle of specialists, was a kind of silence. Not a silence anyone imposed. A silence that simply happened in the gap between how science talks and how the rest of the world listens. The textbooks did not change. The documentaries kept telling the old story. The model Webb is straining against is still, officially, the model. And the evidence straining it sits in journals most people will never open, written in a language designed never to alarm. You were not deceived. You were just handed the photograph instead of the earthquake. So let's be clear about what is actually on the table. Because the most uncomfortable possibility is not that we got a few galaxies wrong. It is the one sitting underneath. Everything we believe about the early universe hangs on a single number: how old it is and how fast it has been expanding. That number is how we turn distance into time. It is how we can say, this light is 13 billion years old, and mean anything by it at all. It is the ruler we measure the entire cosmos with. And that ruler is already in trouble. For years now, 2 completely different ways of measuring the expansion of the universe have produced 2 different answers. One method reads it from the ancient light of the early cosmos. The other reads it from objects in the nearby, present-day universe. They should agree perfectly. They do not. And the gap between them has stubbornly refused to close, no matter how carefully anyone measures. This is not a rounding error. It is a crack in the foundation that has been slowly widening for over a decade. Now, lay Webb's impossible galaxies on top of that crack. Because if our ruler is even slightly wrong, if the universe is a little older, or a little younger, or expanding in a way we do not fully grasp, then the deadlines those early galaxies supposedly missed might not be real deadlines at all. The galaxies might not be breaking the laws of physics. They might be telling us that the clock we used to write those laws was never set correctly in the first place. That is the quiet thought running beneath the careful papers. Not simply, we found strange galaxies, but what if the timeline itself is the thing that is broken? What if the most fundamental measurement in all of cosmology, the age and the expansion of everything, has been subtly off this entire time? And these galaxies are just the first place it became impossible to ignore. We do not know. That is the honest answer. The people doing this work do not know yet, and they are right not to pretend otherwise. It might resolve into a thrilling new understanding of how the first stars ignited. Faster, fiercer, and far earlier than we ever imagined. It might force a revision of the cosmic timeline. Or it might be the loose thread that once pulled unravels far more than anyone is ready for. But here is what you can hold on to tonight when you look up. The universe you were taught about, the one with the tidy beginning and the slow, patient assembly of everything, was a model, a good one, the finest we had. But it was a story we told because it was the story the evidence seemed to support, and the evidence just changed. Somewhere above you, right now, in those deep and silent patches of sky, light that left its source before the Earth, before the Sun, before our galaxy took the shape we know, is still arriving. It has been falling toward us for 13 billion years, and it carries a message that a 60-year-old theory was specifically built to rule out. It reached us anyway. The strange thing about living at the edge of what we understand is that the edge keeps moving. It does not ask permission, and it does not wait for the textbooks to catch up. The people who learned this first did not stay quiet because they were hiding. They stayed measured because that is the job. The drama simply never made the trip from their papers to your screen. Until now, you are a brief, conscious flicker on a small world, staring out at a beginning that no longer makes sense. Once, that thought would have felt like pure dread. Maybe it still does. But there is another way to hold it. We are the first generation that ever got to look this far back, and the first to discover that the story was incomplete. That is not the end of understanding. That is the moment right before it changes. But the impossible galaxies are not the only thing Webb found that almost nobody said out loud. 120 light-years from here, close enough, in cosmic terms, to be a neighbor, Webb turned toward a single small world and studied the air around it. And in that air, it detected a chemical that, here on Earth, has only ever been produced by one thing: living organisms. The team published the result. They were careful. They reached for every hedge the language allows, and not one official sentence used the word that everyone reading the data was already thinking. That is next week. This is Deep Field, where space stops feeling distant.